Okay, right. Antenna are used for transferring and receiving radio waves. Information is transmitted through radio waves by modifying the amplitude or the frequency of a radio wave according to information to be transmitted. Earlier, the first technology was amplitude modulation. We call it AM transmission. We call it AM transmission, but the receiving the quality was not good. We were not getting quality receiving. But later, they use FM transmission of frequency modulation, which is of high quality, stereo, and everything. Right? Nowadays, we don't use this regularly. This is the one that we use, FM range. And in Sri Lanka, legally, it is allowed 88 to 108 megahertz of range for FM transmission, for radio transmission. So that's what they are telling. 106.5 105 96.8 වගේ තියෙනව නේද? That they are referring to the frequency range of them. Megahertz ගන්න තමයි කියන්නේ. ඒක ඒගොල්ලෝ purchase කරලා තියෙනවා. Other people can't use it legal. Only they are legalized to use them. If other people try to use it, they can take some legal action. Okay. Then we go to the next section, sound. Okay. Now we can hear different types of sounds. The sounds are originated by some kind of a vibration. If there is a sound, there should have been a vibration, but every vibration will not produce a sound. Okay. The sound we hear can be categorized as noises and music. The type of energy that produces the sensation of hearing in our ears is known as acoustic energy. And because of the energy carried by the sound waves, our eardrum vibrates and we get the sense of hearing. Okay. Any kind of a sound is produced by a certain vibration. In musical instruments, sound is produced by vibration of strings, membranes, and air columns. There are three basic types of musical instruments, and we'll be studying about it later. Many animals can produce sound waves by different mechanisms. So we are producing sound by the vibration of the vocal cords. Apart from that, different animals are there. They also can produce different kinds of sound by different methods. The frog named Hyla can produce sound by vibrating two membranes in its mouth. So Hyla is a small frog, but to its size, it can produce a huge sound. Humans produce sound by vibrating vocal cords in the larynx here, sound box. Bee produce sound by moving its wings to and fro repeatedly. Very fast movement of the wings can produce the sound of that bee and mosquito also. Sound of the mosquito is by the fast moving of wings. Cricket by rubbing their wings together. Again. Right. Propagation of sound waves. So the sound is propagated from one place to another by longitudinal waves. So as you can see, there's a speaker, and in a speaker there is a cone which moves back and forth when working. You may have seen when you switch on your setup and increase the volume, you can see the speaker is bumping. So when the cone comes forward, the air molecules will get compressed. So that will create a compression, and the compression will move along. And when the speaker cone goes back, it creates a rarefaction. So that's how the sound wave moves. When the membrane in the speaker, the cone, vibrates, the sound is produced. The diagram shows how the wave is propagated along the air. When the membrane moves forward, the air molecules pushed forward and give rise to a layer of compressed air. Due to the kinetic energy, molecules push forward along with other molecules by transferring energy to them. So this is how the membrane works, compressions and rarefactions. When the membrane moves backward, a region of rarefactions is formed in the air layer adjacent to it as shown in above. When the membrane moves forward, another layer of compressed gases is formed, which moves forward. The membrane alternatively generates compressions and rarefactions in the air, all of which travel towards with the same speed. Sound propagates through substances except vacuum. Below are some speed comparison. Now, sound is a mechanical wave, so therefore it requires a medium for the propagation. So the sound waves can travel in air at 330 meters per second, in water 1400 meters per second, and in steel 5000 meters per second. As you can see, sound waves are capable of traveling in all the three states of matter. So that means it requires a material medium for the propagation. Whales and dolphins use sound waves to communicate in water. Sound of a train can be clearly heard through iron rails. So if you keep your ear on the railway line, but be careful. There should be some other people also, because when you concentrate on listening to the sound of the train, sometimes you will hear that it is coming very far away, but if you are really unfortunate, it may be few feet away. So therefore be careful. So according to this example, they are telling the sound waves can travel 5000 meters per second in an iron rail. Very high speed. That means 5 kilometers per second. Sound wave can travel 5 kilometers in this much of time. Snakes can detect vibrations in the ground through its lower jawbone. These vibrations are then transmitted to its ear through the bones, can hear footsteps. Now, even if you cover your ears, still you hear something. You cannot 100% stop your hearing. The reason, the vibrations of the bones will send the signal to your eardrum, right? You can't stop 100% hearing by covering your ears. That is impossible. Yeah, according to this example, when you keep your ear onto the railway line, most of the time, if you hear the train is coming, it may be 5 kilometers away or above. But according to this example, yes, more than 5 kilometers ahead, right? Okay, sound waves cannot propagate through a vacuum since it needs a medium to propagate. Okay, now there's an example to prove that medium is required for the propagation of sound waves. Now, this was an activity done in grade 7 or 8. I can't remember exactly. By using a bell jar, we can prepare a certain setup. So we have to insert a mechanical bell into a bell jar and cover from top and bottom. You have to seal it airtight. Then there is a tube taken out from it, and wires are connected to the bell. So once you switch on, you can clearly see the bell is working. The bell hammer hits on the bell cap, and the sound is also very clearly heard. We can hear the sound of the bell. And while it is ringing, we switch on the vacuum pump and take the gases out. So when the gases are gradually removed, the intensity of the sound gradually reduces. Finally, if you manage to remove all the gases from the bell jar, you might not be able to hear the sound of the bell, but you can see that it is working, but you can't hear the sound. The reason, there is no medium within the bell jar in order to propagate the sound wave. That's why you couldn't hear it. Okay, so this is a simple activity where I don't need you to give notes. You can read it and understand. Right? Every information needed is here. All the information is here. You can prepare a small note. Okay. So I have got the next tute updated also. It is uploaded. So you better prepare it, because when we are doing with the help of a tute, we can go much faster than writing everything. So you have to prepare the note, right? Then we'll fill in the blanks. Speed of sound. Okay. Now, according to what we know, sound is a type of a wave, and the waves are propagated. They will move from one place to another. Because of the movement of the sound or the propagation of the sound, you can hear me. The sound produced by me comes to the microphone. Okay. Then speed of sound. A moving thing has a speed. So speed of the sound depending on many factors. That's what we are going to look at. Now the example that they have taken is the lightning, incident of a lightning. So at the point of lightning, both light and the sound are produced at the same time. Because of when the thunderbolt is traveling in the atmosphere, it produces immense temperature. And some around 5,000 degrees Celsius it produces. And as a result, the gases around the thunderbolt will expand suddenly and contract. So that will create the thundering sound. Right. So now, when there's a lightning, first we hear the light, we see the light, then we hear the sound. So what is the reason? The reason is the speed difference of sound and light. So this is the speed of sound. So according to it, 330 meters per second. So this is the speed of sound, right? 330 meters per second. So when it comes to light, this is the speed. See the difference? Because of this enormous difference of speeds, we can see the light as the lightning takes place. We can assume that it takes no time at all, but sound slowly comes. So definitely the light wins and sound follows. So if you count the number of seconds between the lightning and the hearing of the thundering sound, you can make a guess what is the distance between you and the place where the lightning occurs. If it had taken 10 seconds for the sound to reach you after seeing the light, 330 has to be multiplied by 10. So it is somewhere around 3,300 meters away from you, the lightning has struck. And this is the way that you can check whether you are at a safe distance from the lightning. So if the value is getting less, then the situation is dangerous. Okay. Right, we can write like this. In that note, that blank you can write. Sound can propagate. Sound can propagate. Here, you have to write here in the dotted lines. Sound can propagate from one place to another from one place to another at a certain speed. At a certain speed. At a certain speed. During lightning, during lightning, during lightning, during lightning, light and sound, light and sound, light and sound are produced at the same time. Light and sound are produced at the same time. Produced at the same time, but due to the speed difference, due to the speed difference, due to the speed difference of light and sound, due to the speed difference of light and sound, light and sound, it takes more time, it takes more time, it takes more time for the sound, it takes more time for the sound to reach us, to reach us. Right now you can write the values on the board. Sound speed 330 meters per second, light speed 300 million meters per second, or else easily 300,000 kilometers per second. Both are the same. But this is more understandable when compared with this one. මේක වඩා හොඳට තේරෙනවා. මේව කරද්දී කිලෝමීටර් ලක්ෂ 3ක් යන්න පුළුවන්. You can write this. Okay. Okay, we'll go to the note. Now, the speed of sound is depending on two factors, right? Next point you can write. The speed of sound depends on the temperature. The speed of sound depends on the temperature. Then you can write what I'm writing on the board. 0 degrees Soladi 330 meters per second. Then in 30 degrees, it is 350 meters per second. So this is the variation. When the temperature is increasing, the sound speed also increasing. Okay. So again, depending on the material also, the speed of sound changes, but we don't have to write it again because we have already discussed it. Okay. Now comes characteristics of sound. Now, even without looking at the person, you can easily identify your friends by their voices. You can identify them by listening to the voice of them. You don't have to look at the face. So the reason there are certain characteristics in the sound. Then again, by listening to the sound of the engine of a vehicle, you can identify what the type of vehicle is, whether it is a lorry, a van. Sometimes they can say, and some technicians, the people who are working in the garages, they can tell the error of the vehicle just by listening to the sound of the engine. Garage එකට හරවද්දි මෙයා දන්නවා ලෙඩේ මොකක්ද. හරි. sound එකෙන් කියන්න. So that is because of the different characteristics of sound. And if you compare the male and female voices, you can easily identify whether male is speaking or a female is speaking. There are some special cases, but normally you can identify whether male or female is speaking depending on the sound that they produce. Right. So the speed of sound, we use 330 meters per second. That is the convention. That's the normal value that we give. So don't worry. So this is the value that we use most of the time. We are not going to use this one. Most of the time we use as a practice. So don't worry about it. You don't have to argue it. Right. And if needed, they will give the value for the calculation. They will give the value. Then only you can do the calculation. By listening to sound from different sources, we can say about the source and the strength of them. This is due to some identical properties of sound. Voice of females is softer than males. It is said like that. They have a higher frequency. We have a lesser frequency. Sound of thundering is loud. Sound emitted by violin is soft. These special properties are called characteristics of sound. There are three characteristics of sound. Actually, there are three of them: pitch, loudness, and the quality of sound. It is here. You can write them: pitch, loudness, and quality of sound. These are the three properties of sound. Okay. So then we had to look at the pitch. Pitch. To show that pitch depends on the frequency. Now there's a small activity. You have to draw these two diagrams. I'll draw it on the board. So now these are hacksaw blades which are connected to the table. The first one The first one is with a shorter vibrating length. The second one with a longer vibrating length. So when they are vibrating, you can easily see A has a higher frequency than B. Okay. This has a high frequency. This has low frequency. So these two diagrams you can draw in that box. There's a box, you can write it, draw it. Okay. මම හිතන්නේ ඇදලා ඉවරයි ඇති. Then that you can write like this in that dotted lines, please write. මේකේ ඕන screenshot එකක් ගහගෙන ටක් ගාලා ලියමු අපි. මෙහෙම ලියන්න. Vibrate a hacksaw blade. Vibrate a hacksaw blade. Vibrate a hacksaw blade by maintaining two vibrating lengths. LENGTHs, bigger. Two vibrating lengths. We can see the shorter one will produce a wave with high frequency and the longer one with less frequency. We can say the wave in A has a high pitch and the wave in B has a low pitch. Next point, we can conclude the pitch is depending on the frequency of the sound wave. Okay, so now we know something about the now here in this small strip like boxes there, we can write this sentence. I'll write the sentence on the board. This is for that small strip. පටියක් වගේ box එකක් තියෙන එකට ලියන්න. Which is the property of sound that depends on frequency and heard by the ear and sensed by the ear. Sensed by the ear. කනට දැනෙන දෙයක්. Pitch එක කියන්නේ. Right? You can write that. Right, okay. So after that small strip, there's another sentence you can write. Now it is there's a device in some of the laboratories which is called the cathode ray oscilloscope, and by using the cathode ray oscilloscope, we can observe the shape of the wave. Now you may have gone to hospitals and you may have seen that ECG machines where that wave goes about the heartbeat information, right? In that one, there's a green color graph will move according to the heartbeat. Now here also, there's a small display in this machine. Once we fix a microphone and we talk to it, the shape of the wave will be display on the screen. By that, we can identify the shape of the wave. Okay. We can write here after that line. Right? To observe the shape of the wave, to observe the shape of the wave, to observe the shape of the wave, we can use a device called, මෙතනින් බලා ගන්න පුළුවන් spellings, cathode ray oscilloscope. We can use the device called cathode ray oscilloscope. Cathode ray oscilloscope. ඒ device එකේ actual shape එක නෝක නෙමෙයි. මේ නිකන් පෙන්නන TV එකක් වගේ ඇඳලා තියෙනවා. ඒක ඇත්තටම නෙමෙයි හොඳ. ඊට වෙනස්. කමන්නේ. Just an idea is enough. Cathode ray oscilloscope. Okay. Now we have to draw the shape of the wave in this box. Page number 14 වල යටම තියෙන box එකේ අඳිමු. Wave shape එකක් අඳින්න මෙහෙමයි. මේක බලා ගන්න අඳින system එක වරද්දන්න එපා. නැත්නම් කැත වෙනවා මේක. There is a technique. So first I am going to draw the center line. Then take your ruler, measure 1 centimeter from the center line. and mark a small dotted line. මේ වරදින් නැති වෙන අදින විදිහ කියන අනිත් පැත්තෙත් 1 cm line එකක් ගහලා. හරි. ඊට පස්සේ මෙයාවත් ඔය 1 cm වගේ බෙදාගන්න. ඊට පස්සේ මේ මදි. ලස්සනට එනවා වරදින්. See? You can draw it nice. So that's how you do it. එහෙම ඉදි ගහන්න එක අත්‍යවශ්‍ය නැහැ. ඒ වුණාට මේ වැඩේ ටික ලස්සනට කරනවා නම් ඔය තමයි කරන්නේ. සෙන්ටර් ලයින් එක ගැහුවා. සෙන්ටිමීටර් ගැප්ස් තියලා ඩොටර් ලයින්ස් ගැහුවා. ඊළඟට මේ සෙන්ටර් ලයින් එක සෙන්ටිමීටර්ස් වලට බෙදුවා. Then draw it like this. Okay. You can draw it in the small box on your tute, page number 14, the bottom box. Adi. Okay. So after that, by using cathode ray oscilloscope, we can send the wave we can see. We can see the waveforms of low and high frequency sound waves. So this is the way that we can see the sound waves. We need to draw two diagrams. Again, 1 centimeter line, 1 centimeter line. Okay. Here also 1 centimeter line. One centimeter line. Here I'm dividing this into 2 centimeters. This into 1 centimeter. So this will be the wave, and this is the other wave. So as you can see, here the wavelength is greater in this one than this one. So this is low pitch, low frequency.